Hello everyone, welcome back to CSC Core Concepts in my series of machine learning algorithms with implementation in RStudio. In this video, I am going to demonstrate the clustering algorithms, that is the k-means clustering algorithm. In case you have missed my video on the k-means clustering theory, I suggest you to please go through the video so that you can understand how does the k-means clustering algorithm works. Now for the demonstration, I am using a wine dataset where there are many parameters to deter, and based on that we are going to cluster the different types of wine. So alcohol content, malic acid, ash, magnesium, total phenols, flavonoids. These are all the parameters based on which the wine categories are being done. So before proceeding, we have to include the library files. So the library file which we will require to perform the clustering is library cluster. Okay, so now let us read the wine data. It is a CSV file and you can see that a data frame has been created of 178 observations and there are 13 variables, that is there are 13 parameters. Based on that, the wine classification or the clustering will be done. So let us have a look at the structure of the data. So we can see the structure of the wine data. So you can see here that the alcohol is a numeric variable. All of them are mostly numeric variable except magnesium and proline, right? So we don't need to change here since it is not a classification problem. We don't need to convert it into the factor variable. Now in case if you want to see some scatter plots, okay, if you want to see that how does the relationship goes, let's say for example, I want to plot alcohol versus your flavonoids. Okay, what is the relationship? Okay, for the wine data. So always you can have a look at the scatter plot here. So you can zoom and you can just see the plot. How does it look like? Okay. So this is the relationship between them. So this is what the grouping has been done. This is just a rough idea which I am giving you. Now a very important parameter in k-means clustering is suggesting the k value. So what is the ideal number of clusters would be good for you. Now to determine what is the ideal k value, if you remember we have discussed something about called as an elbow method. So we are going to pass k number of clusters randomly and let the algorithm compute the within cluster sum of squares, and based on that it will tell us what is the ideal value of k where the graph will be taking a turn of a elbow, right? So let us say for example we are just passing that, let's say a maximum value of k will be given because it is a heuristic approach. So it will just do it. Okay. So for that we have to do some pre-allocation of memory. So let us pre-allocate some memory and we will create a vector, creating a vector. Let's say the name of the vector I am giving NA of size 10 cross 1. Okay, yeah. So objects are stored in the drive classes, right? So for elbow method, what do? We write a for loop, right? So how many times your algorithm should work? 10 times, right? And every time it is going to compute the within some square, sum of squares, and based on that it is going to plot the graph. So within sum of squares, WSS is equals to, you are going to repeat, that is the for loop for the vector, because you have to store the results. Why did I create this vector of size 10 cross 1? Because I want to store the within sum of square values 10 times. Why 10 times? Because I have given k max as 10. I want to repeat the loop for 10 times and I am storing the results in NA, right? So n cluster is equals to list. So for, you can take a loop, I is equals to 1 to k max, what are we going to do here is that, just a minute, yeah. So we are going to write drive classes is equals to k means wine. You are going to perform k means for this many number of times. So let us see. Let us say we are going to just a minute. Yeah, I have not executed this. K max 10. Okay. Now let us say WSS we are going to create. N cluster is a list. Okay. And I have done this for loop. Okay. Uh, Okay, so 1 minute, we have to add some more drive classes we have done. Okay, so we have to store the within sum of squares. Okay, that we will store here. That is equals to drive classes total. This is the function total dot within ss. Okay, which will compute the within sum of square, and n cluster, that is the number of cluster we are going to store. So this is what we have declared here, n cluster, that is the number of clusters, and for each number of clusters we are going to store the WSS. So number of clusters of I is equals to drive classes, that is we are going to compute the size of the cluster. So let us execute this one. Fine. So this has been done. This has been executed. So now if you want to see the plot, okay. If you want to see the plot, let us see the elbow plot, right? So let's plot it from for 1 to k max. We want to plot. What we want to plot? The within sum of cluster WSS. Then type is equals to, we want to see both points and lines, right? So we will say type is equals to B. So if you are writing B, if you want P is points. So if you are saying B, then it will be both types, points and lines. So X on the X axis, I want the number of clusters, and on the Y axis, I want, that is the total sum within clusters. Okay, so let us see the plot. Okay, so this is the plot. So what do you understand? Where is the elbow shape we can see? We can see the elbow shape is 4. Okay, there is a curve over here. There is a drop, but still it is dropping. So I think after this 5, this is 5, right? So from 6 onwards, it is almost stagnant. So this way I can consider 5 as the optimal number of clusters, because there is not much difference between the error in 5, between 5 and 6. So let us consider k is equals to 5. So let us now apply k means algorithm for how many clusters? 5 clusters. So the wine cluster, let's say, is equals to the algorithm we are going to call is the k means algorithm, and we are going to pass it on the wine data. And for how many clusters we will do? 5 clusters. So we are going to create 5 clusters out of it, and let's see the clusters. Let's execute it. Okay, so these are the clusters you can see. So which values are going in which cluster? The first value is going to first cluster this way. Okay, second, third and fourth are going to the fourth cluster. So these are just representing that which data point is going to which cluster. So the first 2 data points belong to the cluster 1, next 2 belongs to cluster 4, and so on. So within cluster sum of squares is equals to, this is the value which you are getting. Understood? So for the first cluster, this is the error, and so on. Second cluster, this is the within sum square of sum of squares. third cluster, fourth cluster, and fifth cluster. So we may want to see as a plot also, right? It will be very beautiful looking if I want to see the cluster plot. Okay, that will help us to plot all the cluster for the wine data, the number of clusters you want to compute print. Okay, that is, sorry, in the clusters you want to show. Let's say color, we want color is equals to T, so we want some colors. Shading, okay, fine, let's say we can have shading. Labels is equals to 2 and lines is equals to 0. Let's see. Let us see the cluster. So you can see some clusters here, right? So you can have, there are various colors, right? So this is marked here. First cluster, second cluster, this is the fifth cluster, third cluster, and here comes the fourth one. The green is marked, 4 is marked with the green. So this is the fourth cluster. This is the first cluster. This is a very, very bigger one. Then this is the second cluster. Both are marked with blue. The third one is marked with pink and fifth one is marked with red. Okay, so you can try this problem so you can understand how this K-means clustering works. So what did we first do is that first we applied the elbow method to find out the optimal number of clusters. So elbow method is done by doing the algorithm repeatedly, doing the K-means clustering for some maximum values, right? So for each value we are computing the within sum of square, we are storing it in a vector, that is an array, right? So we are storing, we have declared of size 10 cross 1 and we are storing the number of clusters as a list. So we have computed the within sum and we are storing in WSS and a number of cluster size, that each cluster contains how many values, right? That we had wanted to know, right? So you can see here, yes, so you have plotted this maximum and within the clusters, then we determined that 5 is the optimal number of clusters, and then we got this plot is showing us, is depicting how does it look like, right? So within, so you can see that how many elements belong to the first cluster, second cluster. So 5 are created and for each of them the between sum of square error is being computed. So I hope you understood. So in my next video we are going to discuss about the hierarchical clustering algorithm. Thank you. Don't forget to like, share and subscribe to CSC Core Concepts. Thank you.